Welcome back to topic 38 for Algebra 2, solving logarithmic equations. In part 2, we are going to practice using the property of equality to solve logarithmic equations. So if x is greater than 0, then log base b of x equals log base b of y if and only if x equals y. So we're going to apply this property in solving problems. We're going to use the property of equality for logarithmic equations. Let's say we have the example 3 to the x plus 1 equals 5 to the x. So using the property of equality, we can raise both to the power of 10 and then take the log of both sides. So what that would simplify to, from what we learned in part 1, is log of 3 to the x plus 1 equals log of 5 to the x. Now what we know here is we can use the power property of logarithms. So we can take this x plus 1 and bring it down, and also take this x and bring it down front. So we end up with x plus 1 times log of 3 equals x times log of 5. Then we can use the distributive property here. So we can apply this log of 3 to both the x and the 1 and also multiply this here. So we would end up with x times log of 3 plus 1 times log of 3, or just log of 3, equals x times log of 5. So I'm going to rewrite that for this slide. So we have x of log of 3 plus log of 3 equals x times log of 5. Now what we want to do here is we want to move the term so that we are able to factor out our x. So notice, because we want to solve for x, we have an x over here and an x over here. So making sure that our equation is balanced, what we're going to do is we're going to subtract x log of 5 from both sides. And we'll get x log of 3 minus x times log of 5 plus log of 3 equals 0. Then we want to subtract log of 3 from both sides to get it to the other side so that we're able to eventually solve for x. So we'll end up with x log of 3 minus x log of 5 equals negative log of 3. Now, because we both have our x on this side, we can factor it out. So we'll end up with x times log of 3 minus log of 5 equals negative log of 3. Now, because we want to get x alone, now we're going to divide. And on the left side, we'll get x equals negative log of 3 divided by log of 3 minus log of 5. And here we can calculate using our calculator because they all have a base of 10 for the log. So I'm going to go to Desmos and plug in. So we have negative log of 3 divided by log of 3 minus log of 5. And we end up getting 2.150660103. So rounding to the nearest thousands place, we would get 2.151. So that would be approximately 2.151 for x. Moving on to the next example, here we have 2 to the 3x equals 7 to the x plus 1. So using the property of equality, we would end up taking the log of both sides. So we get log of 2 to the 3x equals log of 7 to the x plus 1. Using the power property, we'd bring our exponents down in front. So we'd end up with 3x times log of 2 equals x plus 1 times log of 7. Now on the right-hand side, we can apply the distributive property. And we'd end up with 3x times log of 2 equals x times log of 7 plus 1 times log of 7, or just plus log of 7. Now again, we want to move our x's to one side, so we're going to have to subtract. So I'm going to subtract my x log of 7 from both sides. And we're left with 3x log of 2 minus x log of 7 equals log of 7. Now, because we both have an x here and an x here, we can factor them out. So we would get x times 3 times the log of 2 minus log of 7 equals log of 7. And now in order to solve for x, we're going to divide. So when we divide, we'll end up getting x equals log of 7 divided by 3 log of 2 minus log of 7. We can plug this into our calculator, and we'll get log of 7 divided by 3 times the log of 2 minus log of 7 equals 14.5726791, which is the same if we round it to the thousands place as 14.573. So x is approximately 14.573. Moving on to our next example. Now sometimes we have the natural logs instead of just the regular logs. So using the property of equality, because we have the ln of both sides, then that's the same as saying, well, x squared minus 16 equals 6x. Now here we have a quadratic. And we know how to solve a quadratic. We can factor, we can use the quadratic formula, we can solve by completing the square. Here, let's see if we can factor. So I'm going to subtract my 6x so that it's on the left-hand side, and I can set my equation equal to 0. So I'm left with x squared minus 6x minus 16 equals 0. Now here, I can factor this as I end up getting x minus 8 and x plus 2. So I want to think of the factor pairs that multiply together to get negative 16, but when I add them, I end up getting negative 6. So negative 8 times positive 2 gets me negative 16, but negative 8 plus 2 gets me negative 6. So using the property of equality, that's saying that x minus 8 equals 0 and x plus 2 equals 0. I'm sorry, that's the zero product property. My bad. We can add 8 to both sides, subtract 2 from both sides, and get that x equals 8 or x equals negative 2. Now here, my only solution is x can equal 8. And that's because this answer is extraneous. Now, why is it extraneous? Why can we not include it? Because logarithms, including natural logs, only include positive numbers. You can only take the log of a positive number. You cannot take the log of a negative number. And because we're plugging x into our log up here, into our natural log, we can't take the log of a negative number. Moving on to our last example, log base 5 of x squared minus 45 equals log base 5 of 4x. Now here, notice how we don't have a log base 10. That's okay. Using the property of equality right here for logarithmic equations, because these match, we can set our arguments equal. So x squared minus 45 equals 4x. Now again, this is a quadratic, so we're going to subtract 4x from both sides to get this set equal. So we get x squared minus 4x minus 45 equals 0. You can also solve this using the quadratic formula or again completing the square. So let's try to factor it. Practice those factoring skills. Now what will multiply to get negative 45? Well, we know that 5 and 9 get you 45. So we could either have negative 5 and positive 9 or positive 5 and negative 9. But when we add them, we want to get our answer of negative 4. So if we add negative 5 plus 9, that gives us positive 4. And if we add 5 and negative 9, that gets us negative 4. So that's our answer. So our two factors will be x minus 9 and x plus 5. Using the zero product property, x minus 9 equals 0 and x plus 5 must have to equal 0. I should say, or x plus 5 equals 0. If we set them equal, so x could either equal 9 or x could either equal negative 5. But again, this is considered an extraneous solution. So we will not include it, and our answer here will be x equals 9. Thank you for watching.